This is an atom, the smallest particle of an element that still retains the properties of that element. The nucleus of the atom contains the protons and neutrons, are most of the mass of the atoms. Electrons that orbit the nucleus, only a small part of the mass. The energy that keeps the nucleons together are actually from the mass. If the nucleons were free, not in the nucleus, they would have a mass greater than together in the nucleus. This missing mass is converted into the binding energy to keep the nucleons together. The difference between the mass of the nucleus and the sum of the masses of the nucleons of which it is composed is called the mass defect. Three things are known in order to calculate the mass defect. Let's see, the actual mass of the nucleus, the composition of the nucleus, which is the number of protons and neutrons, the masses of a proton and of a neutron to calculate the mass defect. You add up the masses of each proton and of each neutron that make up the nucleus. Subtract the actual mass of the nucleus from the combined mass of the components to obtain the mass. Let's do an example. Find the mass defect of copper-63 nucleus if the actual mass of a copper-63 nucleus is 62.91367 AMUs. Let me tell the people! Alright, go ahead then, Mr. Atom. Find the composition of the copper-63 nucleus and determine the combined mass of its components. Copper has 29 protons, and copper-63 also has 63 minus 29, 34 neutrons. The mass of a proton is 1.00728 AMUs, and a neutron is 1.00867 AMUs. The combined mass is calculated. 29 protons times 1.00728 plus 34 neutrons times 1.00867, or 63.50590 AMUs. Let's calculate the mass defect. Take the 63.50590 minus 62.91367 to get a total of 0.59223. Thanks, Mr. Atom. Let me take it from here. The energy as calculated in the previous example is the nuclear binding energy. However, nuclear binding energy is often expressed as kilojoules per mole of nuclei or mega electron volts, MeV, per nuclei. Convert the energy to kilojoules per mole of nuclei. We would simply employ the conversion factors for converting joules into kilojoules and for converting individual particles into moles of particles. I think it's time to wrap this up. Yep, take it away, little guy. So, the mass defect is basically the difference in mass between the nucleons together to the nucleons apart. This mass defect was turned into binding energy to keep them together in the nucleus. Albert Einstein was right. That's all for today, folks. Thanks for watching. Calculate.